As you remember from the previous slide, the primary purpose of a level 1 control is to identify working time arrangements that may not provide an adequate sleep opportunity and as a result require additional controls. There are two broad ways that we approach this problem. The first is around compliance with some set of rules of rostering. The second is what we would call fatigue modelling or biomathematical modelling, and there are a number of software packages that enable you to plug the roster that is proposed or has been worked, and that will analyse all of the factors that we've talked about in terms of time of day, length of wakefulness, length of breaks, and provide some mathematical analysis of the level of sleep opportunity associated with those rosters. It's important to remember that there are quite significant readings in this section of the course, and we will expect you to have looked at some of those in detail so that as we go forward and ask you questions in the assessment, you will be familiar with some of the detailed work in this area. But to start off with, let's look at some of the level 1 controls. What we're going to do is provide you with the Holden Camry and the Rolls-Royce versions at the extremes. There are many in between, as you'll see from the readings as well, but what we'd like to do is to provide you with some simple alternatives. At the low level, the paper and pencil approach that anybody can use, and at the high end, the fatigue modelling approach that's probably most suited to large organisations, particularly those who have a strong safety culture within them. A couple of years ago, we were asked by organisations to provide some advice on how they could work out whether rosters were or were not providing an adequate sleep opportunity. Partly the reason for this was that I got really sick of people calling me up and saying, is this roster good or is that roster bad? And we thought about this and we decided that there were a couple of key dimensions that organisations need to think about in terms of determining whether a roster provides a sufficient sleep opportunity or not. As you can see from the slide, those 5 key dimensions are the number of hours a week that you work, the length of any given shift, the length of time between subsequent shifts, the amount of time you spend working at night, and then what we refer to the reset breaks. This is like the traditional weekend where you have a period of 2 night sleeps with a day off in between, and this would correspond to the traditional Saturday night, Sunday off, Sunday night, and then recommence work the following Monday. For those of you who have a mathematical bent, the minimum break duration required for a reset break is between 30 and 32 hours. As those of you working in the transport industry will see with the new reset breaks that form part of the new AFM guidelines under the NTC. So let's look at how we can do that. This table provides a very simple approach to calculating or estimating the likelihood that an individual will be fatigued based on the roster that they are working. If you look at the top row, you will see that in the left-hand side we have the particular dimension of the roster that we're assessing, and then across the top you will see that the table contains a number of columns labelled 0, 1, 2, 4 and 8. If a value for a particular dimension falls in that value in the row associated with that dimension, you will add the number of points associated with that column to determine the level of risk. So for example, if we look at the first row, that is the number of hours worked in a week, if it's less than the 36 hours on the scale, then that means that there is no additional increase in risk. On the other hand, if somebody's working more than 55 hours a week, the risk will go up by 8 points. Your job when you look at a roster is to look down each of the 5 dimensions and then rate the roster according to where it falls on each of those dimensions. So if you take each of those dimensions and work them across, you'll see that if all 5 of the dimensions ended up in the green zone, you would have an overall score of 0. Conversely, if all 5 dimensions ended up in the black column with 8, you would have 5 times 8 is 40. So this scale goes from a minimum of 0 to a maximum of 40 points. And depending on what points you get for which dimensions of the roster, you will get a score that goes somewhere between 0 and 40 points. Now, you're going to ask, what happens if my roster is more than 7 days, or what happens if it cycles over 28 days instead of 21, or those kind of things. This is a simple technique for assessing a 7-day roster. If you've got a roster cycle that is longer than that, then you can break it up into 7-day periods and then assess each of those. Generally, you're trying to look for the points in the roster that are most at risk. And as you can see from each of the 5 dimensions, the purpose of the dimensions is to measure the extent to which they steal sleep opportunity. So typically the worst parts of the roster will be where you're working really long hours or working particularly long hours at night. The important point to understand about this particular approach is that it is a tool, not a rule. The purpose behind this particular approach is to give you a rough and ready analysis of the extent to which a work schedule or a working time arrangement or a roster deprives you of sleep. And each of those 5 dimensions look at the relative reduction in sleep associated with a roster and then rate the likelihood based on those scores at the top. So let's have a look at what a range of rosters could look like, and we'll see those on the following slide. As you can see here, we have a stylized graph that shows you the range of scores from 0 to 40. We've labelled it in the range 5 to 30 because that's where the vast majority of rosters provide scores. And then on the bottom you will see a stylized graph that shows the score and the level of controls required. And this is a really important point to understand. When we look and assess a roster, it's not it's acceptable or not. We look at a roster and say, what is the likelihood that it will produce fatigue? And if the likelihood is extremely high, the question then becomes what controls will be required to be put in place in order to work that roster. This is an absolutely critical point to understand. We do not say a roster is or is not acceptable. What we say is the risk assessment indicates the level of controls likely to be required. And as such, an organisation will say to us, we're not going to work that roster because we can't afford the controls associated with implementing it. This is a really, really important point to understand. No roster is ruled in or out by definition. It's about finding the appropriate balance between the likelihood of fatigue and the controls that will be required in order to manage it. If one is taking a strictly risk-based approach, this is what one does. One doesn't say this is or isn't acceptable. This is very important when organisations are negotiating with employees or employees are negotiating with organisations. Sometimes people may want to work a particular roster because it's operationally convenient or it has an appropriate social life associated with it, or because they want to commute long distances because of the money. If people choose to work a roster with a high likelihood of fatigue, then you must implement the appropriate controls, that they must be, relatively speaking, proportional to the increase in the likelihood of fatigue. So as you can see from this graph, as the scores go above 5, you need controls, and the more they go above 5, the more controls that you need. To give you some idea of where rosters fall, the vast majority of rosters fall between around about 5 and 21 or 22. We see some, particularly those in the mining industry, that move to the right of that. There are very few rosters we've ever seen with a score higher than 30. Going back to that general principle we talked about before, where this is a tool and not a rule, sometimes people will say to us, well, Drew, when I use this, should I include commute times or not? And as we will say to people, well, do it with and do it without, and that will tell you something. So if you add the commute times in, and it takes the roster from a score of 10 to 20, that will tell you that your commute times are a significant contributor to an increased likelihood of fatigue. Similarly, people will often come to us and say, the guys want to work roster X and we want them to work roster B, and then you do the comparison, and one group of people want a score of 22 and somebody else wants a score of 21. Is that a big difference or not? Well, scores of 1 or 2 difference probably aren't worth worrying about too much. Our general rule is if it doesn't make a difference of 5 or more, it's probably not that important. Similarly, rosters where you have a score between 0 and 5, for all intents and purposes, have minimal likelihood of reducing the amount of sleep that somebody gets. A roster that scores between 5 and 10 will reduce sleep a little bit. A roster between 25 and 30 will reduce sleep potentially quite a lot, and you need to make sure the controls are in place in order to manage that. Do not use this as a new form of enterprise bargaining agreement and a new rules of rostering. It's a tool for assessing the likelihood of fatigue associated with a particular pattern of work, or to choose between competing patterns of work. The organisations that we work with who typically use this approach are in the project management areas, a lot in mining and construction where they have jobs. You have to put a roster together for a 3 or 6 month project, and different rosters are required depending on the organisational and operational requirements. This is a nice simple tool that line managers can use to get a quick idea. You can pretty much be safe in assuring that if it's a 5 versus a 15 versus a 25, the 5 will be a lot less fatiguing than the 15, which will be a lot less fatiguing than the 25. Are there significant differences between rosters of 20, 21, 22 versus 19, 17? You know, it's a tool and it has blurry lines on it, so don't become obsessive compulsive about the scores either. It's a rough and ready tool. The beauty of it is because it provides a numerical output, organisations can draw some lines in the sand to shape how they use such a tool. So, for example, in many of the organisations we work with, if the roster proposed is less than 5, you don't have to do anything about it. You just go ahead and do the roster. If the roster score is between 5 and 15, you have a one-up approval process. So somebody one-up in the organisation can approve that. If you want to score between 15 and 20, you need to have risk controls in place. If you need a roster above 25, then the general manager has to sign off it, and there better be a whole lot of controls in place. There aren't hard and fast rules on that, but organisations typically take a proportional approach. That is, if it's on the left-hand side, you don't need a lot, and you don't need a lot of higher up approval. If you're going to move to the right, and particularly once you go over 25, you better have some good controls, and you better have somebody senior within the organisation sign off on it. The second type of level 1 controls that have been developed over the last few years are what are called fatigue models or biomathematical models of fatigue. These are software packages that enable you to plug a roster in, and they will give you an analysis of the likelihood of fatigue or the level of sleep opportunity afforded by a specific roster or pattern of work. As distinct to the previous tool I showed you, these are much more likely to be used in environments where people's work schedules are varied, typically in transport such as road transport, rail or aviation, or in organisations where the roster is continuously modified by overtime or unplanned changes. It's important before we go on to the use of these particular models that you understand how they've been developed. We're not going to explain to you the fourth order differential equations, but if you understand at least on a conceptual level how these particular models work, it will be useful in terms of understanding both their strengths and their limitations when applied to the workforce. The scientific basis for most fatigue modelling programs is based around the very simple idea that depending on when we have time away from work will influence the amount of sleep that we will get. This goes back to that time of day curve that we showed you at the very start of the course. Because humans are diurnal, we are much more likely to spend time away from work at night asleep than we are during the day. The following graph shows the likelihood of a worker being asleep at a particular time of day, and it shows that it varies, as does the amount of sleep in a given sleep opportunity. So if you look at that line, you'll see that where the square bars are on the left, that is the normal nighttime period, and you'll see the probability of a worker being asleep varies at around about 80 to 90% across that period. On the other hand, if you take a sleep period during the early afternoon and evening, which is the second bar on the right, you'll see that the average amount of sleep is down around 20 or 30%. Without going into too much of the mathematics, if we measure the area under the curve based on where the individual's timing of the break is, it will translate into relatively higher or lower proportions of that period spent asleep. To put that in very practical terms, if I have a break from 10 p.m. at night till 8 a.m. in the morning, that is a 10-hour break, I'll probably get 7.5 hours sleep. If I have a similar 10-hour break between 10 o'clock in the morning and 8 o'clock the following night, I'd be lucky to get 2 or 3 hours sleep. By superimposing the timing of work and rest periods over the sleep propensity curve, we can see the likely amount of sleep that will be obtained in each of the breaks that an individual has. And we can use that to plot the sequence of sleeps that people have had over a period of time based on their roster. Fatigue modelling programs use the timing and the duration of the work and non-work periods in order to estimate the most likely sleep-wake patterns and then the consequent level of work-related fatigue associated with a roster. If you look on the graph, you will see that we've divided time into alternating periods of work and non-work periods. Within the non-work periods, the fatigue modelling software will estimate the likely timing and duration of the sleep periods, and then on the basis of that information, the likely trajectory or course of fatigue across the work period. So you'll see in this particular graph, the purple work periods are preceded by a relatively close sleep period, a significant period of time off, and then another sleep period. Conversely, on the right-hand side of the graph, you will see that there is a single sleep period between two work periods, then a reasonably long period before that individual starts work, has another period of time off before they sleep again. If we know the pattern of sleep and wake estimated by the software, then we can make quite reliable predictions about the likely fatigue levels that an individual will experience on the basis of that work pattern. Based on those very simple principles and a little bit of complicated maths and programming, we're then able to plug a roster in and then get a score out that reflects the level of fatigue across each point of the shift. On this diagram, I've shown you an assessment of the likelihood of fatigue using the most commonly used software package of its kind in Australia, which is FADE, also used extensively overseas, but there are many other packages also used for this, such as FAST, Safety, etc. Again, one of the readings will outline all of the different models that are around and the ways that they can and cannot be used and approaches for how to interpret the information coming out of them. This will form a critical part of the assessment in this course. So if you look at this graph, you will see that across time we have a shift there and that the fatigue score is represented by the purple line with the little scores on it. And you can see across this shift, which happens to be a night shift, that fatigue goes up and up and up, reaches a high point at around about 5 o'clock in the morning and then starts to decline again and then drops very quickly. The reason it drops is because the shift is over and these software packages measure only work-related fatigue, so we're not interested in people's levels of fatigue outside of the workplace. The question then is how tired is too tired? And what happens with most of these packages is that we will draw some threshold values based on either the fatigue or alertness score that comes from the package. And you will see here that those critical threshold values, again using a motif that you will see many times over the rest of this course, go into a green, yellow, red and black zone. And what we usually say is that where the score falls below some threshold, in this case at 80, then the likelihood of fatigue is low. Between 80 and 90, it increases. Between 90 and 100, increases more. And in this particular case, we have set a threshold value of black as anything over 100 points. If you see the way the lines have been drawn down, then the shift can be represented as a point of time where for the purposes of the analysis, the shift starts in the green, goes yellow, red, and then goes black. The purpose of doing this is by looking at the roster, we can see that the likelihood of fatigue in the first part of the shift is low. It then elevates through the yellow, red, and then finally reaches a point where it turns black in the early hours of the morning, where it reaches a peak around about 4 or 5 o'clock in the morning. By overlaying this analysis over a roster, we are able to see where the greatest likelihood of fatigue will be. Does this tell us anything that we don't already know? Probably not. Most people know if you've been awake for a long time in the early hours of the morning, that's where fatigue will be the highest. And that's what we would expect. Where these systems become really useful is that they actually provide the capacity to quantify this. We can tell what proportion of the shifts at what times the likelihood of fatigue is highest, and that provides the basis of a reporting system for fatigue. Going back to what we talked about earlier in the course, part of the difficulty is that most organisations find it difficult to talk about fatigue, and in many cases don't have a language for quantifying the likelihood and risks associated with fatigue. I found it quite interesting that when you use these kinds of tools for analysing rosters, you can be sitting around with a whole bunch of engineers who are panicking over the fact that they have blown their fatigue budget by 3%. And these are the same people who 6 months ago would go, I don't understand fatigue, it's a vague, subjective state. Yet by using some of these models and quantifying it, we achieve a very valuable outcome. That is, if you can't count it, it doesn't count, is often a way that people will think about organisations. And in many cases, it provides the basis for accountability. There's nothing particularly magic about these software packages other than they provide a reporting structure so that people are potentially accountable and that they have a common language for discussing the likely fatigue consequences of different rosters. This table shows you an example of how some organisations have approached the use of fatigue modelling and how they have instituted accountability frameworks for the organisation on what rosters and how they run their rosters. This is an example taken from the rail industry, and as you will see there again, this recurring theme of green, yellow, red and black, and you will see that the likelihood of fatigue is based on an analysis of fade using threshold values of 80, 90 and 100. You'll see if you look on the left-hand side for the given task, the likelihood equals the risk. So you'll see there in the low risk category, that is for fade scores less than 80. The moderate risk or likelihood category is for scores between 80 and 90. The high likelihood or high risk range is between 90 and 100, and then the extreme range is for scores 100 plus. The general principle that you'll see emerge from this course is that where it's green, you don't have to do much. If it's in the yellow range, you have to do a little bit. In the red range, you do a lot. And in the black range, don't go there. So the general principles for organisations are to work on analysing the roster using one of these mathematical analysis tools. And you will see there two columns after the scores, the planned values and the actual values. And these are targets that the organisation imposes upon itself in order to determine that they are providing an adequate sleep opportunity for their employees. And you will see there that employees are required to do a couple of things. You'll see in the bottom of the plan, you will see under the extreme category, we don't ever expect you to plan to go into the black zone. And conversely, if you go to the top right, in actual fact, that is what actually happens on the day, if you get it right 95% of the time, you're probably doing a pretty good job. And then you'll see within the yellow and red zones that there are some flexibilities provided that enable people to have small excursions outside of that 80 framework, provided that they are appropriately managed. You will also see that there is a slippage between planned and actual, because as is the case in many organisations, things don't always go according to plan, and we accept the fact that there will always be a little bit of slippage. The difficulty, however, in an organisation is to make sure that the slippage is constrained and you don't end up with a slippery slope argument. So you will see, for example, in the extreme likelihood box, that while we do not ever plan to go into the black zone, we only get concerned if we go into the black zone more than 1% of total hours worked. In this case, in a rail organisation, their decision was that sometimes trains get derailed, sometimes people do actually have to work long hours because of the possibility of accidents happening to the fact that they're not working. So they allow up to 1% of hours to be worked in that black zone. But as you will see from the actions required, that you have to do a please explain almost immediately afterwards, and then you have to respond to the regulator and explain why you did what you did and what actions you are taking to prevent that happening in the future. As you will see with the moderate and the high range, the same principle hold. That is, we expect you to get into the moderate range or below 99% of the time on plan, and we expect you to plan 100% of your hours within the red zone or below. And conversely, there's some slippage in the sense that as long as you get greater than 99% on the red zone, you're doing all right. And you'll see that the actions required in terms of where you violate that are based on the general principles of safety management systems. The important point to understand with this particular table is not that the values are written in stone, but that the organisation has developed this as a form of self-imposed rigour on how they will run the system. Some organisations use different values to those depending on what the risks associated with the likelihood of fatigue are. So for example, in the aviation industry, those values will be typically 10 or 20 points lower. In the road transport industry, they can be 10 or 20 points higher. In some rail organisations, particularly where automatic train protection and the safety infrastructure is much greater, those levels could also be appropriately higher. And in other organisations, we may find where they are operating in dark territory, where there isn't any safety controls in place, those numbers may be proportionally lower. The exact numbers themselves aren't the issue. What is important is there has been a comprehensive process for assessing the risks, looking at the consequences, and establishing what are feasible and practical levels of performance that can be reported at a management level, and most importantly can be inspected by the regulator. Some of you may have seen the use of fatigue modelling technologies in your workplace, or some of you may be trying to look at the implementation of those. These are a potentially contentious form of technology, and there's a lot of misunderstanding about what the biomathematical models or fatigue modelling software tools can and cannot do. The important point to understand is what the models actually measure. And it's important to understand that they are not necessarily a good tool for measuring a given individual on a given occasion. As a general rule, fatigue modelling software is a very effective way of measuring the degree to which the organisation provides people with an adequate sleep opportunity. And if you think back on the occupational health and safety legislation and your obligations as an employer under that, this is a reasonable way to use these models. That is, they provide you a measure of the extent to which you have provided employees with an adequate sleep opportunity. That's the primary goal of a level 1 control. The difficulty about using these models is that sometimes, because of the appeal of the technology and the simplicity of the use of the interface, people have tried to use these technologies in ways that they were not designed for and are probably not scientifically valid either. For example, people have used these software programs to look at an individual's level of fatigue, particularly after there has been an incident, and on the basis of the analysis, inferring whether that individual was likely to be fatigued or not at the time of the accident. This is clearly an inappropriate use of the models because, as you remember from the previous slides, the models estimate the average likely duration and timing of sleep, not what happened to a specific individual on a given day. This is a very important point to understand, and as with any new technology, the risks of it being used inappropriately can be quite high. It would be very useful to go back and read the specific readings in this section of the course so that you understand what these models do and don't do, and how it is most appropriate to use these for reporting performance with respect to fatigue within the organisation, and how regulators are likely to be using these kinds of tools when they use them to assess the quality of your fatigue risk management system. The important point to understand is that these are statistical models that tell you about the global population. They are a very effective global risk assessment tool and a very effective way of indicating what the risk is across the entire workforce. They are, however, extremely limited in their applicability when you try to predict what happens to a given individual on a given day. In order to manage a given individual on a given day, we typically move towards level 2 controls.